I just slide right here. All right, let's take a look at some of these problems here. We have the gateway test tomorrow. Won't probably take the whole block. We'll probably we may do a few review. We'll see. We may do a few review problems at the beginning if you want to. I don't know. It seems like a lot of times though people come in and want to get going. Want to get it going right away. So we may do that too. We'll see. Plan on being ready to go right when we get in class. And then here we have the derivative rules here, but that's your one chance. Tomorrow's your one chance in class to take the gateway, get 8 out of 10 or better, get 30 out of 30 on the quiz grade. After that, you either take the grade that you got, or come in. You can do one a day. Okay, so I'll get them graded right away. So that night, tomorrow night, you should be able to check on Power School. If you have a 30 out of 30, it means you passed it. And if there's no grade in there, it means you did. So you can take another one on Thursday at some point. It's got to be outside of class time, though. Okay? Lunch, you have a free period after school, before school. And then if you can try, if you pass it on one of your next 2 attempts after that, then it's 28 out of 30. And then we kind of start running out of days, but you could, if you do one each day. The idea is that you would then study a little bit and figure out what you missed and, kind of get caught up. The thing you got to keep in mind is we'll be going on to other new stuff too. So you have to stay up on top of that as well. So kind of your last day to really focus on this stuff. All right, the rules, again, this is posted on the website, this PDF, if you want to, a lot of you wrote it in your notes. Get your product rule, quotient rule, chain rule, the power rules, the exponential rules, the log rules, sine and cosine and tangent, cotangent, secant, cosecant, and then the last 3 we just learned yesterday. Now, there was one question in the homework on arcsecant. You won't have any of those. Okay, if you turn back in the section, they show you arcsecant, but actually you can turn arcsecant into arccosine pretty easily and then use the arccosine. And I'll show you here in a second how that would work. But so let's take a look. I want to make a comment about the first 6. When you have arcsine, number 2, when you have arcsine of square root of 3 over 2, remember, these are functions. These are functions. So arcsine of square root of 3 over 2 is asking a different question than, slightly different question than this question, when does sine x equal square root of 3 over 2? Those are 2 slightly different questions. Much like these are different questions. What's the solution to x squared equals 9? And what is the square root of 9? Okay, those are 2 different questions. One is the square root function. It only has one output, because to be a function, it has to have only one output. The square root of 9 is 3. The solution to this equation is plus or minus 3. Right? Unless we restrict the domain of this and say x can only be positive, then we can throw out the negative solution. Well, that's the same thing here. When does sine x equal square root of 3 over 2? Well, let's see. That's at pi thirds. Is that right? Is that what you had for that one? But also, where else does sine equal square root of 3 over 2? Not only at pi thirds, where else? 2 pi thirds in the first and second quadrant, and then every 2 pi multiple of those, right? So if you go around and around, so that's at plus 2 pi n. So there's an infinite number of solutions to this unless we restrict the domain. And we say solve for x from 0 to 2 pi or 0 to pi or whatever. Okay? This has a restricted domain in it automatically. Sine only looks at values from negative pi halves to pi halves. So that's the first or the fourth quadrant. Well, square root of 3 over 2 is positive value, so it wouldn't be in the fourth quadrant, it would just be in the first quadrant. So the answer to this is simply pi thirds. And that's it. It's just one answer. So the arc sine, arc cosine, they are functions, so they can only have one output for any one input. Okay? So they're similar questions here, but not quite exactly the same thing. All right, before we do some of the derivative ones, look at, in your book, please, if you turn to, on page 191 there, look down at question 37 and 38, and they've got that graph there. And page 191, where the homework was. All right, and they say that in the directions, they say that this equation, arc sine of x, or excuse me, arc sine of the sine of x equals x. I mean, because since sine and arc sine are inverses of one another, and we talked about f of g of x would equal x, if you put x in arc sine, you should get back the same thing. Well, not necessarily, okay? Because what they're saying is if we were to graph this equation, arc sine of the sine of x, we ought to get the line y equals x. And it turns out if you graph that, you don't. You get this right here. So then these questions talk about this. So why would arc sine of the sine of 5 not equal 5? And this is related to what we were just talking about. Okay? And maybe to make this easier, let's do, no, that's fine, let's do 5. Okay? Well, what's the sine of 5? Let's think of the unit circle. Where would that be at? Okay? Because down here, 3 pi over 2, that's like 4.7 something, right? This is 6.28 right here. So 5 on the unit circle would be right over here somewhere. So we would have something like that. That would be 5 radians around here. So sine of 5 would be this. Okay, and it would be whatever these particular values would be. Now, what's the arc sine then of that value? Right? So in other words, it would not be 5, but it would be how much? 2 pi or 6.28. It would, in other words, it was like we were saying yesterday when we thought we'd have 11 pi 6 for that one answer. Remember, go around 11 pi 6, right? But arc sine has a restricted domain from negative pi halves to pi halves, right? So arc sine would actually use this value here, not the value, the positive value going this way. So it would be 6.28 whatever minus 5. Try it on your calculators. Type that in. You'll probably have to hit Control Enter. So approximately 1.28, something like that we might expect. Yes. So it should be 5 minus, right. So, yeah, negative 1.28, right? So, again, but that's kind of like that square root of x squared. Technically, if I do square root of x squared, that does not equal x. Why is this a false statement right here? I haven't put any restrictions on what x is. And think about domain. Is there any limits to what you can put in for x right here? Okay, let's put in a 3. 3 squared is 9. Square root of 9 is 3. So if I put a 3 in for x, I get a 3 out. That seemed to work. But what if I put a negative 3 in for x? Square it, you get 9. Square root, you get 3. So you don't get the same thing out. Now it's close, you get opposite. Turns out if you just put bars around this, then it'd be right. So the square root of x squared is actually the absolute value of x, not x. Okay? Same thing goes for this. It's because of those domain restrictions. So we talk about inverse functions and you put something in, get something out, then you put that back in the inverse, you should get what you started with. Yes, if the domain is properly restricted. Okay, so that's an important concept, important thing to think about. Okay, so you type this in your calculator, you think you get 5 back out, but you don't. All right, so get that out of the way. Now let's talk about the stuff that really matters for tomorrow, and that is these rules. Okay, so let's focus on that. Any questions then on the rest of it?
On 3 and 4,
Yes.
there are 2 that say arc cosine. The domain of arc cosine is 0 to pi, right?
That's right. First and second quadrant. Yes. Okay. All right. Any questions on anything else on here? How about for the derivative rules here? 13 through 24. Forget the RC count. 18?
Yeah.
Okay. Okay, y equals e to the arctan x. So first and foremost, the rule we're using is the e to the u, right? And the rule e to the u is equal to e to the u. So this, the times u prime. Derivative of arctangent is 1 over 1 plus whatever the inside is, which here the inside is just x, and then times the derivative of the inside, which would just be a 1. So since it just has an x, it would be that. And that's really it. I mean, there isn't anything else to do to that. I mean, I could put the e to the arctan x up on top and, write it that way, but that's just rearranging, so it's not necessary. Okay? What else?
22.
22. Arc sine x over arc cosine x. Okay, that's y. So y prime. Okay, derivative at the top, arc sine is 1 over square root 1 minus x squared times arc cosine minus, top left alone, arc sine times the derivative of the bottom, which is negative 1 over square root 1 minus x squared, right? All over arc cosine squared. Right? Any simplifying? Say that again.
The numerator, both of those fractions have a common factor.
Oh, right. And I could do, the one I was looking at was right there, the negative with the negative, turn that to a plus. And so really this is, this arc cosine, think of this arc cosine over 1, so I can put that with that. But I'll be honest, as far as simplifying goes, and this is, you go ahead and do it, you go ahead and simplify, do what Tyler said, put it together. Don't while you're taking the gateway test say, let's see, am I supposed to do this? Will he want me? Don't try to guess. necessarily. I mean, if you go ahead and try to do some simplifying that doesn't work out, you can always go back to what you had. And I will follow your work. I'll look down if you know, I may decide, well, as long as they had it right to here, you know, that's what I'm going to count. You know, if they go and they do some other goofy stuff. Now, if you do some really, really bad stuff, you violate some really serious algebra rules, you know, that may cost you. But in this case, you know, because some people would say if we were in algebra class and we were working on fractions, complex fractions, which means a fraction in a fraction, usually don't like to have a fraction in a fraction, and try to do all that, but we're not going to get that deep into it. I basically said if you can combine some terms or you can factor and cancel some things, then you should do it. But Tyler's exactly right. I could have arc cosine x plus arc sine x all over the square root of 1 minus x squared, and then that's all over arc cosine of x squared. Okay, because I've got a fraction here with that on top and a fraction here with that on top. They got common denominators. I can add them together. And then I could invert, multiply, and so basically this arc cosine x squared could go on the bottom, but that really doesn't allow me to do anything or to cancel anything. So you wouldn't have to do that. So this one you probably even would be good right there.
Can you write the original equation as arctangent of x because it's sine over cosine?
No.
Why not?
Yeah.
You're gonna write over this.
No. If I've got y equals sine, that's a good question because I did want to talk about that arc secant anyway. If you've got y equals tangent x, which is the same as y equals y equals tangent x. Now, if I want to do the inverse, I do this. So I interchange the x and the y, and I get that. Then I solve for y by doing the arctangent. Okay, so that's how arctangent is the inverse. Well, I do the same thing here, so I get x equals sine y over cosine y, which is tangent y, which gets me to here. Now, where was I going with that? I was going to try to change that to arc sine. Oh yeah, I was going to try to get arc. Yeah, see, there's no way here to solve just for y. Yeah, no, it doesn't happen. It doesn't work. Here's what I was going to say about arc secant, though. Remember that y equals secant x is the same as y equals 1 over cosine x, right? Secant and cosine are reciprocals of one another. Okay? If I was to do an arc secant, okay, what would I do the reciprocal of? If you think about it, cosine, what this means is cosine and secant have reciprocal outputs. Let me say that again. Cosine and secant have reciprocal outputs.
So would it just be like negative?
So what would arc secant and arc cosine have? Reciprocal inputs, because you interchange the x and the y. So arc secant x would be the same as arc cosine 1 over x. Okay? So on the problem number, and I'm not going to ask you this,
21.
but on 21, where they wanted you to do arc secant x over 2, if you hadn't memorized the rule, and if you do look on the other page, let's look at 21. Turn back just one page, and x over 2 I would write as 1/2 x. Okay, if you look at the bottom of page 189, they say the rule is this: 1 over absolute value of in this case it'd be 1/2 x, which you wouldn't really need the absolute value for, times the square root of x squared minus 1. Well, that'd be the 1/2 x squared minus 1. Okay, that would be the answer according to the rule. And then you have to kick out a 1/2 because of the 1/2 x. You have a 1/2 on the inside. So according to the arc-secant rule on page 189, that's what it should be. But if we just took our arc-secant and rewrote it as arc cosine of 2 over x instead of x over 2. Now remember, 2 over x is 2x to the negative 1. Then we could just use our arc cosine rule. So we have negative 1 over square root 1 minus, then this would be 2x to the negative 1 squared, right? You keep the inside the same. That's 1 over 1 minus u squared. This is the u. Times the derivative of the inside, which would be negative 2x to the negative 2, like that.
Can't you just multiply that?
Do what now?
Make it like 2x. Cancel the negatives.
Oh, right here. Yes. Now, I'm trying to think. We would have to do a fair amount of algebra to make these. I was hoping that they would pretty quickly and easily look the same, but there would have to be a fair amount of algebra we'd have to do to make that happen. So, if I was going to give you one of these, I would say don't memorize arc-secant. Just remember that it's reciprocal inputs and just do an arc cosine. Okay, there was an AP test a few years ago where they did it. They asked an arc-secant on a multiple choice question. So is that worth memorizing it for that one multiple choice question out of a couple of years on the AP test? That's up to you. But you're not going to have to do it tomorrow. Okay? So those, I think if you type those into your calculator, they would come out the same. All right. Any others? Any others? Well, let's do some practice ones and we'll throw some in here. Let's do this. I think I want to break this up a little bit. I'm going to give you some time here to work with the partner if you want to. On page 195, now some of you, I know I've talked with a few people already that printed out some of the practice ones off the website, so if you want to work on those, you could too. But if you turn to page 195 in the book, now, this does not have any implicit differentiation in it, and it doesn't have any arc sine or arc cosine, I don't believe. Okay, now we just got to practice in a fair amount of those. But let's spend maybe 15, well, some of those get into antiderivatives. I would stick with probably the first 58 or so, 1 through 58 on page 195, and just, get with a partner or two if you want to. And if you've already worked on some of the website ones and want to ask me about them, this will be a good opportunity to get some individual help from me if you want. Okay? We'll go for about 15 or 20 minutes, and then we'll come back together as a group, and then I'm gonna start throwing some up here and have you work them individually to see how you're doing. Okay? All right. So go ahead and work on page 195. Just pick out ones. Just kind of randomly go through there and pick ones out that you want to try. Okay. If you want to work by yourself, fine. You want to work with a partner or two, you can do that too.
What most people want is your battery in there to be easily replaceable laptop.
So.